Welcome everyone. If you're here, it means you're taking your first big step into the world of computational thinking. Now I know when most people hear the word coding, they picture all this complicated text scrolling on a black screen, right? Well, today we're going to blow that idea right out of the water and show you a visual, intuitive, and really powerful way to get started.
So, let's start with the big question, the one that this whole course is about. Are you ready to become a programmer? And look, this isn't just some random question. It's really a call to adventure. This is the starting line for you, the moment you go from just using technology to actually creating with it.
So, how are we going to get there? With this, block-based coding. You can think of it like this. It's like learning a new language by actually having conversations instead of just memorizing a dictionary. It's a hands-on, visual approach where you connect these digital blocks together to build a program. What's so great about this is it gets rid of all the complicated stuff, like worrying about typos and syntax, so you can focus on what really matters: logic, problem solving, and your own creativity.
And that brings us to a really important idea, thinking of this method as the true gateway to programming. Before we jump into the different tools, it's so important to get why this approach even exists. It's designed from the ground up to get rid of that initial intimidation factor, It lets you focus on the number one skill you need, how to think like a programmer.
And let's be clear, this isn't just some simplified toy, not at all. It's a tried and true educational method. Tons of apps and learning platforms use this visual style to build a really solid foundation in computational logic. It makes sure you get the core ideas down pat before you ever have to type a single line of traditional code.
So, where does all this learning actually happen? Well, in this section, we're going to check out 3 totally different digital environments. Let's treat them like our first case studies, okay? It'll help us get a feel for the landscape of block-based coding and see the different paths you can take.
First up, and you've probably heard of this one, is Scratch. It was developed at MIT, and its whole philosophy is built around creativity. It's made for beginners, designed to help you turn your ideas into cool, interactive stories, animations, and games. The focus here is really on creative expression, not just solving abstract puzzles.
Our second case study, Tyner, is really interesting because it plays a special role as a kind of bridge. It uses a fun, story-based approach, a lot like Scratch, but its main job is to help you cross over from visual blocks to professional text-based languages like Python and JavaScript. It actually shows you the path from beginner to advanced coder.
And our third case study, Blockly, is basically the powerhouse under the hood of a lot of other coding apps. What makes it different is that it's an open-source library. So what does that mean? It means developers can take Blockly and build a block-based editor right into their own projects. Its real strength is its flexibility and how it can generate code in languages like Python and JavaScript straight from the visual blocks.
Okay, so we've seen the places where the magic happens. Now, let's learn the language itself. Every language has its own grammar, right? And in the world of block-based coding, that grammar is built on 3 core ideas: blocks, scripts, and sprites.
Let's break this down. A block is like a single word, a simple command like move, or say, or play sound. Now, when you stack these blocks together, you're creating a script. That's your sentence, a full instruction. And who follows that instruction? The sprite. That's the character or the object on your screen. So basically, the script tells the sprite what to do. It's a really simple and logical system.
I love this quote because it just hits the nail on the head. It shows you how physical and intuitive this whole process feels. And that's what's so great about this way of teaching. It makes the abstract idea of coding something you can actually build with your hands, piece by piece. It gets your logical brain and your spatial brain working together.
All right, enough theory. Let's get our hands dirty. We're going to step into our digital lab, the Scratch interface. This is the place where all the ideas we've been talking about really come to life.
When you first open Scratch, the screen is broken up into 3 main zones. Don't worry, it's not as complicated as it looks. Each area has a very specific job, and it's all designed to make building your projects as easy as possible. Let's take a look at each one.
So here's the layout. Over on the right, you have the stage. That's your theater, right? It's where your sprites perform and your project comes to life. Then, on the left, you have the blocks area. Think of this as your library, or maybe your paint palette. It has every single command you could possibly need, all organized by color and category. And that big space in the middle? That's the scripts area. That's your canvas, your workshop, where you drag the blocks to build your program.
Now this is where it all clicks into place. This slide puts a simple Scratch block right next to what that same command might look like in a text-based language. And here's the key takeaway.
Even though you're just dragging a colorful block around, you are 100% using the same logic and structure that real-world programming is built on.
Okay, we've gone over the theory, we've looked at the tools, we've explored the workspace, now it's time to put it all together. We are going to build and run our very first program. This is your first test, and it's going to be your first big win.
Our goal is super simple and clear. We want that cat sprite to move 100 steps across the stage. And we want it to happen right when we click the green flag, which is pretty much the universal go button in Scratch.
Here's how we're going to do it in just 3 easy steps. First, the Start command. You'll go to the yellow Events category, grab the When Green Flag Clicked block, and drag it into your scripts area. Second, the Action. Go to the blue Motion category, find the Move 100 Steps block, and snap it right underneath the first one. See how they connect just like puzzle pieces? And finally, step 3. Run it. Click that little green flag right above the stage.
And just like that, boom, you did it. Success. You have officially written and executed a computer program. You gave the computer a set of instructions, and it followed them perfectly. This little moment right here, this is the fundamental feedback loop of all programming, and you just experienced it firsthand.
We started this whole journey with just a single block, a single command. We've proved that anyone can be a programmer. So the question I want to leave you with is this. If these are the simple building blocks, what complex, interactive, and incredible digital worlds are you going to build next?